given this problem statement, so here x, y, z belongs to the set of real numbers and it satisfies this particular, this is one equation and this is the next one, that is 4 times x square plus y square plus z square, that is equal to a, and the next 4 times x minus y minus z, that is equal to 3 plus a. So in that case we need to compute the value of a, right? So now let us proceed towards the solution. So here it is given, right? So this is given here, that the first equation has, this is the first one that is given, so let me just name it as equation 1 over here for this, and in the next one that is given as 4 times x minus y minus z, that is equal to 3 plus a, and let us mark this one as equation 2. Now here we can say that substituting the value of this a from equation 1, in equation 2, we get, now let us proceed with that aspect after the substitution. So now here first of all I'll consider this equation over here, right, over here. So from equation 1 I'll take the value of a, that is this particular value, and then I'll substitute in this, right? Now so I'll just do it in the next step. So copy this, and in the very next step this value of a I'll take, that is 4 times x square plus y square plus z square. So I'll substitute here, right? And now I'll go through the resolution steps. Now on resolving this and rearranging the terms properly, so here this 4 times x square plus y square plus z square as it is, and this one I'll subtract on both the sides. So this will be negative of this, and then here already 3 is present, so plus 3 is equal to 0. So essentially I have shifted the things towards the left side actually, correct? Now left side of this equation, right? So here 4 times x square plus y square plus z square is written, and plus 3 at last, and this is written here. Now we need to associate the terms appropriately. So you can observe here 4x square is there, so I'll write here 4 times x square, right? Then here we have negative 4x, so minus 4x, right? And then plus 1. So this 3 I will write this 3 as 1 plus 1 plus 1, okay, because I will be distributing this one and we'll get an identity. We can use the identity, a well established identity over here. So one of the 1 from 3 is considered here, right? So I'll just club this part. Now in the next part this one can be written as 4 times y square, 4 times y square, and then plus 4 times y, and here plus 1, this one I have considered here, right? And similarly for z I can write 4 times z square plus 4 times z plus 1, that is equal to 0. Now I'll be using the basic algebraic identity, that is this will be 2x minus 1 whole squared, then this will be 2y plus 1 whole squared, right? And then this would be 2z plus 1 whole squared, 2 times z plus 1 whole squared. Now when you are having this structure, that is a square plus b square plus c square is equal to 0, in that case abc has to be 0, right? So we know this property that when, okay, when a square, when you have a situation a square plus b square plus c square is equal to 0, and definitely abc are real numbers, so in that case we can definitely conclude that abc has to be equal to 0. That is the only situation where you can get this answer as 0. So now we'll just compare each of this with 0, we'll equate with 0 actually. So this one, on equating this one with 0, we'll be getting for x, that is 1 over 2, right? So not this square part actually, only this linear part, correct? And then in the next part, so here 2y plus 1, so instead of this 2y plus 1, hence y would be negative of 1 over 2, and similarly for z as well. So 2 times z plus 1, and z equals to 1 over 2. So now finally we can compute our result that is using this equation, right? So I'll be using this particular equation. So now in the next step, so here instead of x y z we can just substitute the value and get the value of a, right? So instead of x I can substitute here 1 over 2 minus, instead of z, negative 1 over 2, and then instead of z again negative 1 over 2. So here negative 1 over 2, and this is equal to 3 plus a. On resolving this one I'll be getting here 4 times 3 over 2, that is equal to 3 plus a. And on resolving this part, so you can observe here 2 is 4, right? So 2 times 3, that is 6, and 6 minus 3, that is 3. So finally from this equation we can say that a is equal to 3, and hence for this problem statement the value of a is 3, and hence this is the answer for this given problem statement.